Hello everyone, in this video I will go over the solutions to study guide for exam 1. So question number 1 says the following: Pikachu contends that regardless of the specific problem involving finding the volume of by rotating, you can consistently apply the wash or shell method, which means you can use either one. Is he correct? The answer is not quite. So this is true for most problems, but this is not always the case. So therefore, this is not quite true. And the perfect example for that is the following. Let's say that you have a graph that looks like this, okay, which would be just f of x equals to x squared minus 4x or something like this. If you're going to use the washer method and you're rotating, let's say, on the y-axis, the partition has to be perpendicular to that. And here is the problem. Okay, you do a partition perpendicular to the y-axis, then you have the same graph, so you will end up with 0 all the time. And clearly the volume is not equal to 0. So in this case, it will not work. Let's move on to question number 2, which says the following. Any integral that you can solve using partial fractions can unfailingly be solved using trigonometry substitution. Is this true or is this false? Well, this is also not 100% true, but is mostly true. For example, you have something like this. You can clearly use either partial fractions or trig substitution to solve the problem. If you have something that looks like this, in theory you can also use partial fractions or trig substitution. However, that may not be the best case to do it. And by the best case, I mean using trig substitution may not be the best case. So this is mostly true, but using trig substitution, even though it may work, it may not be the best choice. It may not be the best choice, and by that it means that it can get way more complicated, and you may have to end up using also integration by parts and other methods to solve it. So eventually you will get it, but just using partial fractions could be much easier. Now, the opposite is not true at all, and by that I mean the following. You can solve a problem using trig substitution. Can it be solved using partial fractions? And the answer is no. For example, you have this. You can solve this using trig substitution for sure, but because of the square root, the partial fractions will not work. So therefore, this is not true. Okay, so let's move to number 2 now. Number 3, part A. So number 3, part A is asking you to find the volume using the shell method that will result if you rotate x squared, which is the graph of x squared, between y equals to 0, and which is this line, and x equals to 1. So let's say x equals to 1 is here. So essentially is this area, and you need to rotate around the line x equals to -2, which is here. So you are rotating here. All right, so for the shell method, the partition has to be parallel to the axis of rotation, so it should be this. Now notice that the distance between here and here is x, and the distance between here and here is 2. So therefore the total distance is going to be x plus 2. So then the volume, remember, it will be the integral from 0 to 1, because this goes from 0 to 1. of 2 pi, and then the distance is 2 plus x, or x plus 2, and then times the function, which is x squared dx. Then will be very easy to integrate. This is the integral from 0 to 1, 2 pi. Actually, you multiply, it will be 2 pi times x squared times 2. This is actually 4 pi x squared dx. You can break it into two integrals, plus the integral from 0 to 1 of 2 pi x cubed dx. And then this is actually pretty easy to integrate. Okay, so 3b is very, very similar. You still have the same function, x squared from x equals to 0 to 1. So this is the area you're rotating, but in this one, you're rotating along the line x is equals to 2. The partition is, remember, parallel to the axis of rotation. The distance between here and here is still x, but the distance between here and here is 2 minus x. So therefore, the volume is going to be 2 pi integral from 0 to 1. The distance is now 2 minus x, which is this part. This is the distance, which is from here to here. And then the function is x squared dx. And again, this is going to be pretty easy to integrate. This will be the integral from 0 to 1, and you break it into two pieces of 2x squared dx minus the integral from 0 to 1 of x cubed dx. And this should be pretty straightforward. In the exam, you have to complete the integral, but this is pretty simple. All right, then 2 part c, same function. You are rotating now on the line y equals to negative 2. So let's say this is y equals to negative 2. You still have this from 0 to 1. So you still have this. So the partition now, remember, has to be parallel to the axis of rotation. So the partition has to be this. So now you have two functions, this one and this one. So you have to integrate with respect to y. So notice that the distance between here and here is y, and then the distance between here and here is 2. So the total distance is going to be y plus 2, very similar to 3a. So therefore the volume is going to be 2 pi, the integral from 0 to 1, and then this will be y plus 2. That's the distance, which is this, y plus 2. And then this will be 1 minus radical y. Well, how do we get that? So this is the biggest function, which is 1, and this is x squared. But if x squared is equals to y, that means that x equals to the square of y. So that's where the square of y came from. And then, again, to integrate this is pretty straightforward. You have to distribute and then integrate. And then the last part, the main difference is now is y equals to 2 instead of 2, so this is a typo. So you still have the same graph. You have square, let's say this is 1, so this is why you're trying to rotate. And then y equals to 2, it will be somewhere here. Notice that the distance here is still y, and the distance here is 2 minus y. So it's very similar to 3 part b. So therefore the volume is going to be 2 pi, the integral from 0 to 1. The distance is 2 minus y now, which is this part. And then the biggest area is 1, and the smallest area is the square root of y, which is this part. So therefore this will be 1 minus the square root of y, dy, and if you distribute, you'll end up with 2 pi, the integral from 0 to 1. This will be 2 minus 2 radical y minus y plus y to the 3 halves, and then this is also pretty easy to integrate. Okay, now let's move to number 4. So here we need to find the arc length. Remember that for the arc length, you need to take the derivative first. So f prime is going to be 1/2 t squared minus x squared times minus 2x, and it should be to the minus 1/2. So this is equals to x, actually minus x over t squared minus x squared. Because remember, t is a constant, and here the 2 cancels this. Therefore, if you square the derivative, you'll end up with x squared over t squared minus x squared. Then if you do 1 plus the derivative square, this will be 1 plus x squared over t squared minus x squared. If you add the fractions, this will be t squared minus x squared plus x squared over t squared minus x squared. This cancels, so you end up with t squared over t squared minus x squared. And then you need the square root of this, which means let me do that here. So you use the square root of 1 plus f prime squared. It will be the square root of t, which is this, t squared, and this will be t squared minus x squared, so it's squared. So then the arc length, remember, is the integral from 0 to t of t over t squared minus x squared dx. Because remember, t is a constant. Okay, so t is a constant. All right, so here we're gonna have to use a trig substitution. So we're gonna let x to be t sine theta, okay, which means the sine theta is gonna be x over t for later. So the x is equals to t cosine t dt. So therefore, if you plug it into the formula, notice that you'll end up with t cosine t. So you already have the t in here. So you'll have, for this part, you have t cosine t d theta, and then here you're gonna have t squared minus t squared sine squared theta. Notice that you can factor t squared, 1 minus sine squared theta, but the square of t squared is t, and 1 minus sine squared is cosine squared. So this will be cosine squared. So you take the square root, the bottom you end up with cosine theta also. So this and this cancel. So you end up with just the integral from 0 to t of d theta, which is equals to just theta from 0 to t. But theta, from here, theta is sine inverse of x over t. So therefore, this is equals to sine inverse of x over t from 0 to t. t. So therefore this is sine inverse of t over t, which is 1, minus sine inverse of 0. So this will be pi over 2, because sine of pi over 2 is 1. Remember, this thing is equals to 1, then minus 0, so the answer is just pi over 2. Okay, so let's move on to part B. First, state the derivative. Notice that the 2/3 will cancel this, so you'll end with x to the 1/2 minus 1/4 x to the 1 minus 1/2. So minus in here, minus 1/2. Then you square this, you'll end with x to the 1/2 minus 2 times 1/4 plus 1/4 x to the minus 1/2 squared. I just use the fact that this is equals to a squared minus 2ab plus b squared. So here gives you this, okay? And then you simplify, you'll end up with x to the 1/2 minus 1/2. How do I get that? This gives you 1/2. This times that gives you x to the 0. Anything to the 0 power is 1. And then plus 1/16 x to the minus 1. Now, remember you need to add 1 to this, so 1 plus f prime squared will give you the exact same thing as this. The only thing that will change is this. So minus 1/2 plus 1, it will give you 1/2. So you will end up with x to the 1/2 plus 1/2 plus 1/16 x to the minus 1. Notice that this and this are identical, except that this is plus and this is minus, which means this came from something like this but being plus, or in other words, it's a perfect square. So therefore this is the same thing as x to the 1/2 plus 1/4 x to the minus 1/2, the whole thing square. So therefore if you take the square root, which you need that for the area, the square root will cancel this, so you will end up with exactly this part. Okay? And therefore the arc length is just the integral from 0 to 4 of x to the 1/2 plus 1/4 x to the minus 1/2. And this is pretty easy to integrate. The integral for the first one is x to the 3/2 times 2/3, and then plus 1/4 x to the 1/2 times 2 over 1, and all of this is from 0 to 4. So this is equals to 2/3 x to the 3/2 plus 1/2 x to the 1/2 from 0 to 4. So you plug in a 4, this will give you 2/3 times 4 to the 3/2 plus 1/2 times 4 to the 1/2, and all of this minus 0, then whatever that is. Okay, so now let's go over number 5, part A. This problem requires integration by parts. Here it is tempting to use u to be x, but we don't know the integral of sine inverse. So therefore u should be sine inverse of x, and dv should be x dx. So therefore the u will be 1 over 1 minus x squared, and b will be x squared over 2, or just 1/2 x squared. Okay? So let's say that this is the integral we want. So therefore if we use integration by parts, remember the formula is uv minus b du, will end with 1/2 x squared sine inverse of x minus b du. So this is missing the dx. So this should be dx over 1 minus x squared. Now, to integrate this part, you need to use a trig substitution. So therefore, I'm going to call this part just t. So therefore, t is going to be the integral of x squared over 1 minus x squared dx. And to solve this integral, we need to use a trig substitution. The substitution is going to be x equals to sine theta, which means dx equals to cosine theta d theta. And also from here, that means that sine theta is equals to x over 1, because we're going to need a triangle to solve the problem. So this is x, this is 1, and this is 1 minus x squared using the Pythagorean term. So therefore, t is going to be the integral of sine squared, since x equals to sine. Dx is equals to cosine theta d theta. And this is the square root of 1 minus sine squared theta. But recall that 1 minus sine squared theta is just cosine squared theta. So therefore, you take the square root. This is just equals to cosine theta. So therefore, this will cancel this part, and you end with just sine squared theta d theta. However, to integrate this, you need an identity. So recall from trigonometry that sine squared theta is the same thing as 1 minus cosine 2 theta, a double angle, divided by 2. So therefore, this is the same thing as the integral of 1/2 d theta minus 1/2 cosine 2 theta d theta. Now, the integral of the first one is just 1/2 theta. This will be 1/2. You can take the 1/2 out. And the integral of cosine 2 theta is 1/2 sine 2 theta. So we'll plus a constant, which you can put that at the end. So therefore, this is 1/2 theta minus 1/4 sine 2 theta. But notice that the original problem is in terms of theta. And since this is in terms of theta, therefore sine 2 theta is not going to work when we use the triangle. So therefore, you have to change sine to the double angle to a single angle. But also from trigonometry, sine 2 theta is the same thing as 2 sine theta cosine theta. So that's another identity. So therefore, if you apply this in here, you end up with this 1/2 sine theta cosine theta, since the 2 and the 4 gives you 1/2 when you simplify. Now we use the triangle. Remember, sine of theta is equals to x. That means from here that theta is equals to sine inverse x. So therefore, this is 1/2 sine inverse x minus 1/2, and then sine theta, already know, is just x. But cosine theta, so therefore sine x is equals to this, and then cosine theta is equals to radical 1 minus x squared over 1. So remember, all of this represents the solution to t, and I is equals to 1/2 x squared. So from here, sine inverse x minus 1/2 t, but t is all of this, sine inverse x minus 1/2 x, and then 1 minus x squared, and the whole thing plus c, and that's it. Okay, so now let's move on to 5 part B. Here, you technically could use substitution or integration by parts. For this particular problem, substitution could be enough. You can also use integration by parts. It's like you just need to realize that u should be sine x. So therefore, du is equals to cosine x over sine x dx. But remember, cosine over sine is the same thing as cotangent x dx. So therefore, you substitute here. Notice that this is just equals to u du, which is probably the easiest integral we have so far. So this is just u squared over 2 plus c, which is equals to 1/2 ln of sine x squared plus c. Okay, so moving on to part C. Before we start, let's do a substitution. Let's say that w is equals to 4x. So that means the w is equals to 4 dx. So therefore, this is essentially the same thing as 1/4 the integral of tangent to the 5th power of w times secant q of w dw. This is very similar to one of the questions of the participation. So you have two choices to rewrite this. You either have a secant squared out, and the substitution is tangent, or you have a secant tangent, and the substitution is secant. And in this case, that's what is going to be the substitution. So notice that you can rewrite this as tangent to the 4w times secant square w times tangent w secant w. So you can check that this is exactly the same thing as this. So now the only reason why we're doing this is because we want to pick the substitution to be u equals to secant. And if u is equals to secant, then the u is secant w tangent w, which is what we have already here. And we had to make sure that we change everything to secant. We already have secant here, so we had to change this to secant. Now recall the 1 plus tangent square of theta is equals to secant squared theta, which means tangent squared theta is equals to secant squared theta minus 1. Okay, so therefore from here we'll have this is equals to 1/4 the integral of if u is secant, then this is going to be secant square w minus 1 square secant square w times tangent w secant w dw. Okay? So if we made the substitution u equals to secant, then du gives you this part already. So therefore this will be 1/4. This will be u squared minus 1 squared times u squared, and then du. Okay, again, notice here that, okay, if u is secant, this will be u squared minus 1, so I give you this part. and then this is obviously just u square, and then the du takes care of all of this. So then if you use the distributive property or FOIL, whatever you want to call it, notice that all of this, once you use the distributive property, you end up with u to the 4 minus 2 u squared plus 1. Then you have to multiply times u squared, and that will give you u to the 6 minus 2u to the 4 plus u squared. And this is pretty easy to integrate. So this will be 1/4 times 7u to the 7 minus 2u to the 5th over 5 plus 1/3 u cubed, and everything is then plus c. So then finally this will be 1/20a u to the 7 minus 2/5 u to the 5th plus 1/3 u cubed plus c. But remember, u was equals to secant, so this is secant to the 7x minus 2/5 secant to the 5th plus 1/3 secant cubed plus c. So actually I forgot to multiply the bottoms, so therefore this and this have to be changed. That should be this is 20, and this is if this is 12, it should be 12. This is 12 and this is 20, which you can simplify this a little bit more. All right, for this problem, for part D, we're going to use the substitution u equals to e to the x. You can also use u equals to 1 plus e to the x, and you should end up with the same answer. So if u is equals to e to the x, that means that du is e to the x dx. From here, notice that the x is equals to the u over e to the x, but that means this is the u over u. Okay? So therefore, from here, if you plug it in, this will be du over u for this part, which is, this is the dx, and the 1 plus e to the x should be 1 plus u. So therefore, if we do partial fractions, you will need 1 over 1 plus u plus b over u, and this should be equals to 1. So you solve the partial fractions, you have a u plus b, 1 minus u equals to, 1 plus u equals to 1. So if we select u to be 0, so that means b is equals to 1. And if we select u to be -1, that means minus a is equals to 1, or a is equals to -1. So therefore, from here, you will end up with the integral of minus the u over 1 plus u, and then plus the integral of the u over u, since b is 1. So if we integrate this, the integral of the first one is minus ln of 1 plus u plus ln of u plus c. If you substitute e to the x back, this is minus ln of 1 plus e to the x plus ln of e to the x plus c. So notice that this is just minus ln 1 plus e to the x, and then this is plus just x plus a constant, and that's it. Okay, let's move on to part E. This problem is going to require using integration by parts twice. So let's say this is I, so this is the integral we want. So here u will be e to the 2x and dv will be sine 3x. This is one of the few problems where if you interchange the two, it actually will not matter. You end up with the exact same thing. So here du is equals to 2e to the 2x, while b will be minus 1/3 cosine 3x. So we plug it into the integral using integration by parts. Remember, this is ub minus b du, so this will be minus 1/3 e to the 2x cosine 3x minus b du, which is this. Okay. So therefore, you simplify this. This is minus 1/3 e to the 2x cosine 3x plus 2/3 the integral of e to the 2x cosine 3x plus c. And you can add the c to the end, so you don't really need it right now. Okay, so let's call this part from here to here t, and we have to use integration by parts for that again. So for t, you're integrating e to the 2x cosine 3x dx, and here u would be e to the 2x and dv cosine 3x. So therefore the u will be 2e to the 2x again, and b will be 1/3 now sine 3x. And you can verify that by taking the derivative of this, gives you this. All right, so then if you plug it into t, this will be ub again, so it should be 1/3 e to the 2x, but now it's going to be sine 3x minus b, which will be this, du, and du is 2e to the 2x dx. So therefore, so far you have 1/3 e to the 2x sine 3x minus 2/3 e to the 2x sine 3x dx. So therefore, so far, what you have is this. So if we integrate from here, that means the I is going to be equals to minus 1/3 e to the 2x cosine 3x plus 2/3 times of this, which is 1/3 e to the 2x sine 3x minus 2/3 the integral of e to the 2x sine x dx. Okay? So you simplify a little bit more, you end up with the following. It should be plus 2/9 e to the 2x sine 3x minus 4/3. But notice this is very important. This part, notice that this is essentially the original integral. That's I that we start with. So therefore you can just call this I. And then from there the problem becomes just an algebra problem. So it will be like if you are solving something like this, like x equals to 5 minus 4 9x. And you have to solve for x. Here, by the way, this is I wrote this wrong. This should be 9, not 3. So this part should be 4 9s. So therefore, you combine this and this, which is the same thing as moving this to this side here to solve for x. Where you end up with is the following. You'll have I plus 4 over 9i equals to all of this, e to the 2x cosine 3x plus 2 9s e to the 2x sine 3x plus a constant. So you combine this, you end up with I times 13 over 9 equals to all of this. So that means I will be 9/13 all of this, which will be minus 1/3 e to the 2x cosine 3x plus 2 9s e to the 2x sine 3x plus c whole thing. And then you can reduce this more, like here the 9 cancels this reduces with this, but this is good enough. All right, so 2 more to go. Let's go to letter F. For this one, you can use either trig substitution or partial fractions. You want to use partial fractions. Remember, partial fractions only works if the degree on the top is less than the bottom. So you have to do long division first. So you multiply this by 1, you'll end up with x squared plus 1. You change the sign, so this will give you minus 1. So essentially, so notice the x squared over 1 plus x squared is exactly the same thing as 1 minus 1 over 1 plus x squared. So that's what this means. So therefore, I, the integral, is the same thing as the integral of just 1 dx minus the integral of dx over 1 plus x squared. The integral of dx is just x, and then this is minus tangent inverse of x plus c. If you use trig substitution, you'll end up with the same answer, but if you use trig substitution, x has to be tangent theta, and then you should check that you get the same answer. This should be if you want to use a trigonometry substitution. So just give it a try, because you will end up with the exact same answer. And then finally, for this problem, recall the cosine squared theta is equals to 1 plus cosine 2 theta over 2. So therefore, cosine to the 4 of theta is the same thing as 1/2 times 1 plus cosine 2 theta square, the whole thing. So this will give you 1/4, 1 plus 2 cosine 2 theta plus cosine square 2 theta. And then, since this is still square, you have to use the same identity twice, but now with 2 theta. So therefore, this is 1/4, 1 plus 2 cosine 2 theta plus, if you use the formula, then this part is going to be 1 plus cosine 4 theta divided by 2 whole thing. So therefore, you distribute, this will give you 1/4 plus 1/2 cosine 2 theta plus this is 1/2 times 1/4. That will give you 1/8, and then this will give you 1/8 cosine 4 theta. So essentially this is 3/8 plus 1/2 cosine 2 theta plus 1/8 cosine 4 theta. And then this is pretty easy to integrate. So therefore, if you call this I is just the integral of 3/8. Well, all of this should be, now you change to x plus 1/2 the integral of cosine 2x plus 1/8 the integral of cosine 4x dx. So therefore this is 3/8 x plus 1/2 times 1/2 sine 2x plus 1/8 times 1/4 sine 4x plus a constant. And then you can just simplify this more. So this is 3/8x plus 1/4 sine 2x plus 1/32 sine 4x plus c. Now, depending on what the question is asking, you may be able to simplify this more like we did in the previous problems, but since they're not asking you more than this is good enough.